We've all seen those moments on CSI or Criminal Minds, when the detectives are at the crime scene and they have to trace the evidence back to the perpetrator. But how does one actually use forensics evidence to find a killer? Luminol, a vital tool in any CSI's kit, glows blue in darkness when it comes in contact with blood. It is useful because luminol can trace blood even after it's been cleaned up and expose blood that people can't see with their own eyes. Blood, which is made up of liquid and solid components, contains hemoglobin, which is a red protein that transports oxygen. Hemoglobin contains iron atoms that react with the luminol solution. Luminol is comprised of 5-amino-2, 3-dihydro-1, and 4-phthalocene-dione. The commonly used luminol solution spray is a combination of luminol, hydrogen peroxide, which acts as a strong oxidizing agent, and an alkali, like sodium hydroxide. In a basic solution, luminol forms an anion, which is a negatively charged molecule, which can be oxidized by an agent. The last part needed for the reaction to occur is a catalyst, which is a substance that speeds up a chemical reaction but is not absorbed by the reaction. This is where the blood comes in, because the iron atoms in hemoglobin act as a catalyst. The reaction produces a cyclic peroxide, which decomposes to produce a chemical known as 3-aminophthalate. During the reaction, energy is released to the electrons in the 3-aminophthalate molecules, which causes them to get excited and move to a higher energy level. When the electrons eventually move to a more stable level, they release their excess energy as photons of light, thus resulting in blue chemiluminescence. What is chemiluminescence? If you split the word apart, the prefix chemi means that it has to do with chemicals, and the base of the word, luminescence, means that it gives off light. Thus, chemiluminescence means giving off light via a chemical reaction. To understand this more, we can look at a simpler example. In an incandescent light bulb, an electric current is passed through a filament, which is a thin metal wire. Resistance to the current flow causes the filament to increase its temperature, so the metal's electrons become excited and enter a higher energy level state. The electrons relax to their normal state, they release excess energy in the form of light. A chemical change occurs when molecules' bonds are altered, like in the reaction between hydrogen and oxygen to form water. These chemicals have either an exothermic or endothermic reaction. Sometimes chemical reactions where energy is produced is given off as light, not heat. Common examples of chemical reactions where energy is released as light is bioluminescence, which occurs in marine animals and in fireflies. While luminol is an effective way to test a crime scene for blood, there are many problems with its accuracy. The use of luminol solution could potentially damage other evidence like proteins, enzymes, and genetic markers. Luminol can also be toxic, smear blood, and dilute blood samples, so that the DNA is hard to recover and it can be difficult to determine how the victim died. Luminol reacts with other substances such as bleach, rust, fizzy drinks, and coffee, which can produce false positives. This calls into question the credibility of forensics. Today, more than 350 people have been exonerated by DNA testing after going to prison. The United States National Research Council report in 2014 said that nearly anyone with a garage in some capital could theoretically open a forensics laboratory. The Department of Justice and Commerce created a National Commission on Forensic Science to establish countrywide standards so that forensics is more reliable in the future. To see if luminol really worked, I tried out a number of chemical reactions using it. For my first reaction, I needed luminol and blood. I then mixed them all together with a bit of water, and it created a light blue glow. For my next reaction, I mixed a perborate mixture with a luminol mixture, and added a couple teaspoons of water, and it created a bright blue glow. For my last reaction, I wanted to create something that looked like a real crime scene, so I made a basic luminol solution spray. I then poured blood down a staircase in a random pattern to create a realistic blood spatter from a murder. Afterwards, I mopped it up so that you couldn't see any blood. I did this to recreate a murderer cleaning up the crime scene and disposing of the evidence. I then sprayed the luminol solution all over the staircase and turned off the lights. The solution glowed blue wherever it had come in contact with the blood, which shows how crime scene investigators use luminol to find blood which you cannot see. I hope you learned something new about chemical reactions in forensic science. Thank you!